All right, so here we go. This is our last class together, and then the final exam on Thursday. It's a week from today.
Have you posted like a study guide for the final exam?
What's that?
Have you posted a study guide for the final exam yet? Have you posted a study guide for the final exam?
Study guide.
Yeah, like you did the midterms.
No, I don't think I did that. Did I do that? I don't think I did that.
You gave us a list of problems too.
Yeah. So, oh, this
You
is
gave us
this
the
one.
example problems.
You know, this is my other course here. I gave you a list of problems.
Yeah, it's
Okay.
from the
So,
other course. You just copied this and gave us the link.
all right, let me do this. I actually forgot to do this a long time ago. This is a course I taught in fall, and you'll see there's a link to the final exam here. These are old exams I gave. If you're interested in seeing old exams, this is a final. So there's plenty to look at there. That was winter. This is fall. So the final will look like these. They just look like the midterm. And this is not correct. That link's actually not correct. The correct link is this. And this is this will be summer 2016. That's this summer. And then oh, that's spring. I see. So fall. Oh, wait a minute. This goes to fall. Yeah, that's fall 2015. That's fall 2015. This is spring 2016. This is my other class. Yeah, I think that's good enough right there. Yeah, that's good enough. All right. Yeah, and I have, well, I'll give you the summer one as well. Actually, I don't remember the link. Let me find it. This is it here. That's it. That's my summer course. Okay. I don't know if this is of any use to you, but just in case, this is my preparation for teaching in the summer. So, a lot of the problems, I make small adjustments all the time. And maybe some of the problems that I have posted for summer are good to look at. There we go. So summer 2016, final exam here. Oh, not much there. Sorry. But anyway, some other things that I have in there. So last time, what were we in the middle of? We were going through these midterm answers, right? So I was going to continue with that.
Yeah.
Yeah, okay. So we're up to problem 9. And let me get to that. So that's right, the Unix command. Suppose your home directory contains a folder named temp. Show the Unix command to list the contents of this folder. Make no assumptions about the location of your current directory. That means if I say make no assumptions about the location of your current directory, you'll need to use absolute paths. So that's the implication there. And let's take a look here. Let's suppose we have a folder called temp. Let me use this up here. In the home directory, is there a temp there? There is a temp there. And I'm going to create a file inside temp. Say a.out. So pwd print working directory /home/Ubuntu. This is the home folder. Home by itself, that's not the home folder. Okay, it's just a folder named home. But every user in the system, so that your system can have multiple users. So you authenticate as a user. So I'm user Ubuntu. And that's the name of the Linux distribution that they're using, by the way. It's an Ubuntu distribution of Linux. So they just auto-created a user named Ubuntu. And so /home/Ubuntu is my home folder. And under the home folder is a folder called temp. So pwd reveals that working directory or current directory. And you can look in there, there's a file a.out there. Once again, so we have a folder named temp in the home directory. We want to list the contents of this folder. Well, see, it depends. Like right now, my current directory is the temp folder, so I can just do ls. But if I go up to my parent, cd ... see, now I'm in my home folder directly. Then I have to use ls temp. That gives me so ls with no argument is the contents of the current folder. ls with an argument is the contents of the folder identified by that argument. And here, that argument is a relative path to the temp folder, is relative to where I currently am. So if I was in the temp folder, I can't go ls temp. There's no subfolder here called temp. So this command ls temp is relative to my current directory, because that's why it's called it's a relative path. If I was inside workspace, I could do this. I'd have to go up to the parent and then down through temp. And then I can do the listing that way. That's also a relative path. But the problem says, make no assumptions about the location of your current directory. So we need to come up with a command that works from any folder. Well, we have to use an absolute path. So there's an absolute path. It doesn't matter where we are. Look at where we are now. We use this absolute path. We can still see the contents of the temp folder. But the problem doesn't say anything about how to get to your home folder. So actually, to answer the problem, you would need to use this. That's an absolute path. Tilde represents your home folder. It doesn't matter if my username is Ubuntu or Turner or something else. Tilde will work. That gets you to the home folder, regardless of where your current directory is. So that's the answer to 1. That's ls tilde temp. About 10. Here it is. Suppose there is a file named a.out in your parent folder, which is the directory that contains your current directory. Show the Unix command to delete this file. Once again, we don't know where we are in the file system, but wherever we are, we have a parent that contains an a.out. Well, I know inside here, let's make a directory, I'll call it SAM. I'll cd into SAM. Actually, let me do it up here. This is test here, right? Let's go into test. Okay, now inside test, I'm going to make a directory called SAM inside test. See, there's my path. Home Ubuntu Workspace Test SAM. So we're way down inside. We're inside here. Now inside test, there's two things. There's a SAM folder, which is our current folder, and there's an a.out. Now we need to delete the a.out from the SAM folder. So we're in the SAM folder. So we need to remove, we need to go up to the parent and then identify the file in the parent that we want to delete. And that gets rid of it. You know, once again, it's just a matter of practice here. Sorry, I get this here. So it looks like this. That would be the answer for 10. That's a relative path. Here, for 9, it's an absolute path. For 10, that's a relative path, relative to the current folder. This path doesn't matter what your current folder is. We'll always go to temp inside your home folder.
Is there a way to do that absolutely? Like to remove?
This one here?
Yeah. Or do you have to do
No, because the problem statement says in your parent, so you'd have to know what your parent is. You'd have to know what your folder is or your parent folder, and then you could make an absolute path. Certainly, for this particular example that we show, we can make an absolute path, but it wouldn't solve the problem posed by the exam. Let's look at 11. Suppose you have a file named main.cpp in your current directory. Show the Unix command to create a copy of this file named test.cpp. The copy should go into your current directory. Once again, we don't know anything about where our current directory is. But everything we do happens inside of this current directory. So the file we want to copy is in there. The file that we want to create, test.cpp, should be placed in there as well. So we just got to find a main.cpp here. So well, basically it's this. It's copy main.cpp to test.cpp. That would do it. That'll work. Doesn't matter where your current directory is. That works. Let's go ahead and do that. There's a main inside the workspace folder. So if we go, I'm going to go up 2 levels. See that? I'm inside SAM, inside test, inside workspace. So I'm going to go up to test and then up again to workspace. So that's the path to go up two levels. Remember, these things that identify directories and files are separated with slashes in the path. All right, there we go. So see, now we're in workspace. So inside workspace, there's a main.cpp right here. So we want to make a copy of that and have the copy named test.cpp. So we copy main.cpp to test.cpp. Did you see it get created right there? We could check it here as well. There it is. That's the new file that was created. So we don't need that, so just take it out. So that one answers 11. What about 12? Assume there is a folder named Sam that is inside your home directory. So we have a Sam, it's inside the home directory. I'll go to the home directory, cd tilde. I could just do cd, that's the same thing. So the default target of cd is your home directory. So if you omit the argument, the default is to go to tilde, your home. So suppose there's a folder named Sam. Let's make that folder. Oh, Sam already there. Okay. Sam is already there. And I don't know what happened there. There's nothing in Sam. Assume there's a folder named Sam that is inside your home directory. Then we have that. Show the Unix command to move a file named main.cpp from your current directory into Sam. Oh, so we're somewhere in the file system, and there's a file named main.cpp that's there. We want to move it to the Sam directory that's in the home directory. We don't know where we are in the file system, but the current directory is somewhere. So there has to be, we have to use an absolute path to get to Sam, but not to get to main, because main.cpp is in the current directory. All right, so let's look at that. It sounds confusing, doesn't it? So we do have a Sam, and let's go into test. That's another Sam, but it's a different Sam. I'm going to get rid of that so we're not confused. I'm going to copy main that's in my parent to here. So here, current folder is just a dot. So see, it's copy source to destination. The source is the main that's in my parent, because we're inside test right now. So a sibling to us is this file named main. So we want to get to there, so we have to go up to the parent so we get to that sibling. That's our target. That's our, our source. They call it a source, and the destination is the current folder dot. You see how that got dropped right in there? Okay. All right, now what we want to do, if you look now inside Sam under the home folder, there's nothing in Sam. But we want to move main.cpp in our current folder to the Sam folder in the home folder. I could put a slash there, you can leave it out, it doesn't matter. So did you see underneath test, main.cpp has disappeared. Because we moved it away. We moved it to Sam, the Sam folder in the home folder. And we don't see the home folder here. This just shows us the contents of the workspace folder. That's why that's a bit confusing. So there it is. Move main.cpp to the Sam folder in under the home directory. All right. You gotta practice these. You just have to make stuff up like I'm doing and practice them. All right. What about isLucky function? Before I get into that, I want to remind everybody that this link goes to the web page that shows the commands that you need to understand. pwd, cd, cp, mv, rm, mkdir, rmdir, these. and these three special symbols. So the questions that I'll ask on the exam are limited just to these commands. All right, what about is lucky? Implement a function that determines if an array contains more 7s than 13s. A declaration of the function is shown in figure 7. All right. I'll do it here, I guess. So the problem asks to implement this function. If you think about it, let's see, V is, just to get clear, let's take a look at what a lucky function is. So a lucky function looks like this. And sometimes creating an example will help you solve these problems. Here's a lucky function, 7, 7, 13, 3, 13, 5, 7, 0. That vector has 3 7s and 2 13s. So it's lucky because it has more 7s than 13s. What about an unlucky function? An unlucky function. An unlucky vector, rather. Suppose we have that one. That's unlucky because there are not more 7s than 13s. There's the same number of 7s and 14s. But to be lucky, the number of 7s needs to be greater. Needs to be more. There needs to be more 7s. But there are not more 7s. So this is unlucky. Here's another unlucky function. Vector. That's an unlucky vector because there are not more 7s than 13s. Well, there's no 7s and there's no 13s. So that's, see, just to get clear, once again, there's no 7s, that's unlucky as well. So we've got some examples just to help us solve the problem. So we got to count the number of 7s. That's how we decide yes or no whether V is lucky or unlucky. I said that's V, right? Maybe we should call that A. The function is an array, and we use A as the variable. So we have to count the number of 7s, we have to count the number of 13s, and then we compare those two numbers together. If the count of 7s is greater than the count of 13s, we return true. Otherwise, we return false. Now, in some of the problems, like maybe if we redefined the concept of lucky, we said, well, a vector is lucky if there's at least 1 7 there. We don't care about 13s. We just want at least 1 7. So the logic is going to look a little different. We still need a loop. We'll start looking at the values in A. As soon as we find a 7, we'll return true. We found a 7. We can break the loop. We don't need to finish the loop. But in this problem, we have to count all the 7s and all the 13s to get those counts. So we can't break the loop with an early decision. We have to finish the loop and get those counts. Then we can compare those two counts. So there's no breaking the loop in this problem. So we need to have the number of 7s. I could do it like this, 7s. Initialize that to 0. 13s. And then we have the loop. That's length. That's the number of elements in A. We need to increment the that index I. So we need to look at every value, and for each value AI, we compare it first to 7. If A of I is 7, then we'll increment the 7s. Else, if AI is 13, then we'll increment the 13s. And then, we don't need an else here, right? Else we don't do anything, so we just could leave that one out. So that counts the 7s and 13s. Then we do the comparison here. We do, if the 7s is greater than the 13s, then return true. We're lucky. Else, it's the opposite. We'll return false. Now, this code here, there's a shorter version of that. I'll show you that shorter version. Instead of this big chunk right there, we're just going to return the result of comparing 7s to 13s. This line right there, that's good. That's equivalent to this. But whatever is readable to you, if this is more readable to you, can do that. This is how I would write it if I was to write the program. I think programmers like to look for compact expressions. We don't want to overdo it, though. If it's really not unreadable, then you should avoid it. I think this is relatively readable. We want to return true if the number of 7s is greater than the number of 13s. Maybe this one in general, for general use, is better. Better than this one. I'll put that up there as the default answer. All right. That's it. That's the midterm right there. Well, I have in my mind something I think we should go over, but maybe you have some questions or a problem that you'd like to look at first. Nothing? Suggestions? With classes, right? You should be ready to answer a question about classes. So right there, that's the lecture. And let's take a look at this rectangle class. Submit your work. And look here, this is summer 2016 classes. Here. Rectangle class problem, what you did. Number class problem, you did that. Then here's some example questions, how they might appear on the exam. So I might give you a UML diagram like this. And then I have an explanation of how that class works. Here's a description of the class, how the functions work. And then I'll ask a series of questions. So here's 4 questions. So this is a typical exam question. There was 4 of them. I state the class, and I'll have at least 4 questions about the class that you have to answer. Let's do this one here. All right, so we have this number class. Instances of the number class represent integers. Yeah, I probably should call it integer, but I didn't do that. I think I'll change this web page if I can remember. The integer value they represent is passed into the constructor and stored in member variable n. This is member variable n. See the minus sign there? That means it's private. This int means it's an integer, an int, 4 bytes. And so the integer value they represent is passed into the constructor. This is the constructor. See, this third section is where the member functions are. Constructor is a function. It's a block of code that runs when you invoke it. The purpose of the constructor is to initialize an instance of this class, an instance of this data type. Class is a data type. So we pass in the value we want this number instance to represent. And that value that's passed in here to this argument is stored in the member variable n, which is listed in this second section. The second section we use to list the member variables. The first section of the UML diagram, simply the name of the class. So there's a set value function. It takes an integer argument which it copies into its private member variable n. So this is a set value function here. Pass in a new value for the number instance to represent. So we just take the n that's passed into the function and copy it onto or into the member variable n. The isPrime function returns true if member variable n is prime and false if not prime. So isPrime takes no arguments. It just returns true or false based on whether n is prime or not prime. So here's the first problem. Provide an implementation of the constructor for the number class. So that would look like this. I'll just answer them right here. This is what the constructor looks like. This is one possible implementation right there. Oh, not quite right. This is an initialization list. So we pass the value in here, n. We set the member variable n equal to the constructor argument n. Maybe that's not readable to you. So I'm going to show you 4 different ways of showing this. Maybe this is confusing because these are the same letter. So let's change this letter here. That's arbitrary. The constructor now gets, we're using the variable k as the argument to the constructor, and that's what is passed into this initialization expression for n. So if you go n parentheses k, it means create an instance of n and initialize it with k. All right, maybe this one's not very readable to you either. So I'm showing you 4, you only need to memorize one of these. How about if we did this? Let's go back to, we'll leave it at k. Instead of an initialization list, we'll do the assignment inside the body of the function. So n is k. These are all equivalent. I'm showing you equivalent implementations. And maybe you don't like having 2 separate variables, 2 separate names. So we're going to use n for both of these. Oh, but then there's an ambiguity. this n should be the member variable n. So we have to, that has wider scope, so the compiler lets the argument n dominate. So we need to tell the compiler that this left-hand side of the assignment is the member variable n. So we use this arrow n to do that. Here's 4 different ways of implementing that number constructor. This is it. I can't think of anything else. This is all you get, these 4. That was just a lot. I think students will tend to pick this one. I've got someone, yeah.
You said that this points to the member variable?
Yeah, this by itself, just that's a pointer to the instance, the memory that will store the state of the instance. But when I use this arrow here, it means I want to select a member variable that's inside this this memory location that's allocated for this object. You know, it's hard, right? I'm trying to.
Okay, so
Yeah.
the arrow points to the variable that's recurring within the class definition.
Yeah, that's right.
It doesn't point to the one that's simply an input.
That's exactly right. Exactly
quickly
right.
Thrown away once it's used.
Yeah, that's right. This is this n up here is the throwaway n. That's a good way to describe it. That's the throwaway n. And this, when I put a this in front of it, I mean the member variable n, the n that's in the class. It's the n that we preserve. That's a good way to describe it. All right, what about 2? Provide an implementation of the set value function. Well, it's going to look similar to this. I'll use what I think is the easiest for you to use. Now, we've got the set value function. It's going to take a k. It's very similar to the constructor. We're just passing in a new value, k, should be copied into the member variable n. Now, set value is a void function, so we put the data type first. Remember, we need to tell the compiler that set value is a member of the number class, so we need that prefix right there. Once again, I'll show you one alternative to this. If we happen to use the same letter n here for both, then we need to distinguish using this. So that's another way you could do it. That would be the common way to do it. But this is probably better for beginners. And what about the is prime function? Let's implement the is prime function. That function returns a bool. I'll put it up here. Bool. No, I'll put it down here. Bool number is prime. By the way, normally this would be declared as a const. You know, I think for the exam, I'm not going to worry about that. I mean, you don't have to, but it's not a function that modifies the object, so it should be declared const. All right, so we just have to decide, we have to decide if n is prime or not. So, we use our algorithm for that. We just start at 2 and go up 2, but stop at, stop when we hit the value itself, n. And, if if n mod I is 0, then we found a divisor. That means it's not prime. We finished the loop without returning false, then we didn't find a divisor, so it must be prime. I am constantly messing that up. Okay. So that's that standard algorithm we're practicing over and over again. Yeah.
Is it an if or for integer I?
Oh, if, sorry, thank you. I can't believe it. Yeah. That's, every time I see a student do that on an exam, I cringe. This is the first time I've done this myself, so I'm as fallible as you are. Okay. So there it is. See the n, there's no n here. We're not passing n in here. There's no int n, right? Because n is, this function is running relative to this class instance, which is also referred to as an object. It's running relative to this object, and the object contains a value in it, contains an integer in it, which we identify with this name n. See, n is the data that's in there. You can have more than one variable as a member variable, but we just have one here. So that's why we use this n. It doesn't appear in the function at all, in this function signature. But nevertheless, we use it because the function is a member of the number class. That means it has access to the member variables. N is a member variable. All right, what about 4? Provide test code for the isPrime function. Use assert statements for this purpose. Make sure that your test code executes every line of code in the function. All right, so we need to use assert statements, test code. Well, we need to create instances of the number class. Let's create a 7. And I'll call it 7. This, because it'll represent 7s. And we'll do assert 7 is prime. That's good right there. That should return true. 7 is prime. Or you could do this. You know, that's a little redundant, but that's okay. And well, let's test the other case as well. Let's do number 9. And then assert 9 is prime is false. And we have 2 test cases. One returns true, the other returns false. So there's some test code right there. You have to know how to create an instance of the class. That's the syntax. And then you need to know how to invoke a function against that instance. There we use the dot operator. And also you need to understand how to use an assert to express these tests. The assert will silently succeed if the expression you pass into it evaluates to true. That should evaluate to true. This expression should evaluate to true. Because the isPrime returns false here. False equals false. That's what we expected. So the expression evaluates to true. That's passed to assert. Assert just does nothing. So that solves this problem, number. And there's some other problems to look at. There's bean jar, egg carton, You want to look at any of these or do something else? What do you want to do? You want to try to do this on your own and then take 10 minutes, try to figure it out, or what do you want to do? Or just break, we can just quit. Or look at other problems.
Was that gonna be on the test too?
What's that?
The E-jar and
Oh, I don't know what class. I don't know if number will be on there. They're all, these are just patterns to look at. I could ask about, something similar to these, but not the same ones. So you have to grasp the pattern, the concepts, and apply it to new cases. You know, the idea of a constructor and functions. Yeah.
So just for clarity, I barely started the class assignment, so the statements you were going over, that's gonna be outside of the class.
Yeah, this here,
Yeah.
that. Yeah, this is not in the class. This is in the main
bold,
function.
The void and where you're describing those integers.
What, you mean like this?
Yeah.
Yeah, this is not in the class declaration. It's outside. If you were in the class declaration, you can omit this.
And then
So that it might look like if you had this piece of code here. Let's take a look at that. So this is the number class, right? So we would have a file here called number dot. Well, no, let's call it main2. So if we wanted to use this in this main, that means we have to have a class called number. And in there is a bool function is prime. So that's the declaration of the class, and it says the declaration says there's a function named is prime. So we need to at some point later define the function itself, and basically provide the statements that need to execute when the function is invoked. You could put everything inside a class as well. But for a big function like this, you wouldn't do this. You would not normally do this. You wouldn't do this, but just to show you that it can be done. You don't need, because we're inside a number class, this is not needed to tell the compiler anything about where it is. We're in the class declaration. So that will work. But you wouldn't normally see that like that.
there would be tech files.
Oh, and that's another thing you could, this is everything in one file. This is the one with the main in it. So you could do everything in, you could do everything right here. So that's how the test code might look. Of course, you need the constructor that's missing here. So you'd have to add that in there. Oh, I forgot to say the public and private. Right? I didn't get those in there. And this is the constructor. That's the complete program there. That should run and pass. That should run right there. It's a main2. be in the workspace. Cout's not declared. Yeah, we got to add all that stuff in there, right? I need to get that. So it's almost a complete program. But on the exam, you don't need to do all this stuff. What you do on the assignments, this has to work. See, we're just these little details here. All right, now number, what does it say there? Oh, number.
But using namespace.
Yeah, we don't need that because I was using this here. Something to do with the constructor is not, what's going on there? Wait a minute, I gotta clear this thing. All right, let's see what it says. Definition does not declare parameters. Oh, forgot the data type. There we go. So, there it is. Yeah, it takes a while to get it to build and run correctly. So that's how it looks. You know, but once again for the exam, you know, you were just going to show, you know, that for the test code, but you know that's in main. You don't have to show the main around it, not anything like that. And this code here is, you know, defined outside the class. You don't need to show that exterior stuff above it. That's how that looks. You know, you should look at these other problems as well. These are good to work on too. Bean jar, number, egg carton. Here's a constructor. See, this constructor takes 2 arguments. How many eggs are in the egg carton? And how many grams does each egg weigh? I guess that's an average. So we can start out with, you know, say that's an egg carton of 12. I think that's what I said, yeah, 12. So it cannot exceed 12. It's an egg carton with 12 eggs in it. And when you add eggs, maybe you have 3 eggs in it, you want to add 2 eggs. Now there's a total of 5 eggs in the egg carton. And the total number of eggs in that egg carton is represented here. And when you create an instance of this egg carton, you give the average grams per egg. I could have omitted this one here. It's a little, but anyway, that's that. Then there's a get total weight function. So you have to, multiply the eggs by the grams per egg. That gives you the total weight in grams. So it's the same format. Bean jar, similar. You've got a constructor, you know, max beans and beans. Max beans and beans. You know, to implement this constructor, let's look at that. Let's look at this one. So to implement the constructor, it would look like this. It takes these values, and it's this max beans equals max beans. This beans equals beans. So max beans is the capacity of the jar, and beans is how many beans are initially placed in the jar. And then you've got a get beans function. It's const. That's simple. That's just return beans. That's called an accessor function. Add beans returns a bool. Add beans returns a bool. Oh, we got to pass in the beans to add. But we can't add too many beans. We don't want to exceed the capacity. So if the beans that we have plus the beans that you want me to add, if that exceeds the max beans, then I'm not going to do it. I can't add those beans because I don't have enough capacity. So we do that check. That's explained in the problem, I think, here. See, that's described here with an example. So you just have to read the problem and figure it out. Of course, if you don't return false, then we can go ahead and add those beans in there. And then we return true. And we also need to return true. Some people might not like this. I think in general they would prefer this this formulation. I think for most people that's easier to read. If the beans in the jar plus the beans you want me to add is greater than the max beans, I can't do it, I'll return false. Otherwise, I'll do it and return true. I'll add the beans that you passed into my function to the beans in the jar, return true to say that I succeeded. Remove all beans. What about that one? That's a void. Who can tell me how to implement that one?
Beans equals 0.
Exactly. Look how simple that one was. Good job. That's how you remove them all. Very good. Looks like you're getting the hang of it. It's clicking for you. All right. There's test code, how do you, and look, make sure the test code provides good coverage. So test the add beans function. Make sure the test code provides good coverage in the sense that it executes all lines of code in the add beans function. See this add beans function, so we have to reach this point and we have to reach this point. So you'll need at least two cases. So here's the test code. We create a bean jar. I'll call it, jar 1. Oh, it's add beans, isn't it? I'll just call it jar. And it'll have, what comes first? The capacity. Say 100. And we'll start with 40 beans. And then we're going to call add beans. We're going to add 30 beans. That should return true. That'll give us, that gives us 70 beans total, right? In the jar. We could check it too. We could do assert, which is probably a good idea. Get beans. So we check that. So we don't need the comment. If we use the assert, then we don't need a redundant piece of information there. This tells us that we expect 70 beans to be in the jar. But if we try to add 50 beans, there's currently 70 in there. We try to add 50, that should fail because it's too many. So we can only hold 100 beans. And then you might want to have this test, make sure that it stayed at 70 beans. Because I think the problem states, yeah. When the add beans function fails, the number of beans in the jar will not have been changed. And then I give, for the example here, give an example. So that's, that would be the test code. That's how to do that problem. Ready to go? Last day, and then the summer starts. Yeah.
How many questions will be on the plan?
What's that?
How many questions?
How many questions? I think the same as the previous years. So, it'd look like, what was it? This one here? What it would be, that's the latest one there, right? So these are worth 25 points. $20 problems. But there's some that are worth less, I think. Yeah, here. Oh no, not there. These, no? Oh yeah, here. These, oh, I put them all in one problem, I see. These are 25 points. This is the, yeah, so there's 20 problems. I don't know how many problems there are in this final. It's roughly the same amount. Everybody finishes. There's enough time. Nobody runs out of time. Nobody. I don't remember a single time someone ran out of time. And if you wanted more time, I'd let you come to my office and keep working on it. So not a problem. So you don't worry about time. It's just whether you get ready for it or not. Yeah, so there it is. All right, that's that. Anything else? Maybe that's 5 more minutes. Take an extra 5-minute break today. All right, that's it. That's it. I want to remind people about the summer 202 is being offered this summer if you're interested in taking 202. Oh, one other announcement. The Computer Science Club, now called the ACM Club, is doing a study marathon on Friday. And so you can make use of that, the Computer Science Club. I think I have that. If you look at the syllabus, I don't have a syllabus, do I? In my other class, I have a syllabus. And there is a link to their website. No, there is not a link. I don't believe it. Let me find that. Hold on. Student organizations. What is going on? Ay, ay, ay.
But you
What do I gotta do? What is going on there? So. They have a broken website. I don't remember the time that they're meeting, so I'll try to send that information out by email. Okay, that's for Friday. And they have free food, so